So today we are going to discuss a topic about the arithmetic mean. It is individual observations indirect method. In this method, we will calculate arithmetic mean. So this is the given problem. I am reading the problem. Monthly income details of 10 families are given below. From the data, compute arithmetic mean. Family numbers are given 1, 2, 3, 4. Income is given 400, 500, 200, 300, 400, 800, 800. So it may be in rupees. So from this data we have to calculate individual observations in indirect method. So the problem is always given in horizontal manner. So we have to rewrite the problem in vertical or columnar manner. So I have rewritten the given problem in vertical manner. So after that, in this method, in this individual observations indirect method, we have to assume one value among the given values as assumed mean. So formula for this formula for this calculation is arithmetic mean is equal to a plus sigma d by n. Sigma d by n. So a is nothing but a assumed mean. So we can take any value from this series or any value from out of the series. So we can take literally we can take any value. We can take any value as assumed mean, but for our convenience, we have to take two things. From the series, it is the lowest value is 200 and highest value is 800. So give two values, sir. We have to give lowest value and highest value. It is better to take a middle of the highest value and lowest value. So let us will take assumed mean as 500. Assumed mean as 500. So here D means deviations. So deviations from assumed mean. So after that, how to calculate this D? So D is not, it is x minus a. So x is the value. X is the value of the income. X minus a. A means assumed mean. So first we will see the first one, this 400. 400 minus 500. So we are deducting the assumed mean from x value. We are deducting the assumed mean from x value. So we have to deduct assumed mean from each value of x. It shall not be in vice versa. So we shall not deduct every value from assumed mean. So in this calculation, we must remember we will deduct assumed mean from the values of x. So we are deducting the assumed mean from value of x, it is minus 100. So it is 0. It is minus 300. So here we are deducting the assumed mean from every x value. This is for just understanding. We have to put here the direct deducted value. This is for just understanding of the students, I am here writing, we have to put direct minus 100, 0, minus 300. So here also from 300 we will deduct 500 minus 200. It is 400 minus 500 minus 100. 800 minus 500, it is 300, it is plus 300. It is also plus 300. So it is 400 minus 500, it is minus 100. 500 minus 500 is 0. 600 minus 500 is 100. So in this calculation we will get positive values and negative values. In this calculation we will get positive values and negative values. So we have to sum up this deviations at the end. So for the summing up, it is better first we will calculate the positive values. So here the positive values are 300, 300 and 100. So total 700. So plus 700. So negative values, next we will take negative values. Here 100, here 300, 400, 600, 700 and 800. So minus 800. So here if we observe this, its positive values are 700, negative values are 800. So the value of from, if you deduct that amount, it will comes to 100. But the value of the negative digits is, negative values is more. It is 8 minus 800 plus 700. So the amount secured, the value secured, we have to put minus. So it is minus 100. So the total sum of total of the deviations is minus 100. So we will substitute these values here. Arithmetic mean is equal to, assumed mean is 500. So sigma d means total of the deviation, sum of the deviation, it is minus 100. N means the number of values here given. It is 10 here. So 10. So 10. So it is 500 minus 10. So plus into minus, 500 minus 10 is equal to 490. So 490 is the arithmetic mean we found out from this calculation. So this is the method. We have to observe the method. We have to take any value from the given series, or it may be out of the series, but it is better to take given series. It may be between the highest value and lowest value. So here we will take 500 as assumed mean. From that 500, so we have to deduct that assumed mean from every x value. We are deducting 500 from every x value. So in that way we will get the deviations. So after the deviations, after we got the deviations, we have to sum up the deviations. We will get the minus 100 value is a minus 100. So we have to substitute that value in the formula. We will get the 490 as assumed. So this is the first problem from individual observations and indirect method. So we will see the next problem. So this is the second problem in arithmetic mean individual series indirect method. So this is the second problem. The problem, I am reading the problem. Monthly expenditure of 8 industries are given below. Find out arithmetic mean. So industry 1, 2, 3, 4, 5, 6, 7, 8, expenditure in lakhs. So the amount given is in lakhs. 50, 60, 70, 80, 60, 70, 50, 90. So after the question, we have to rewrite the question in a vertical or columnar manner. So I have already written the manner in vertical manner. So here the given question. So after that we have to take we have to assume one value as assumed mean. So first we will write the formula. arithmetic mean is equal to sigma a plus sigma d by n. A plus sigma d by n. So here a means the assumed mean. We can take any value as assumed mean. So we will take here the lowest values are 50 and highest value is 90. So we will take assumed mean as 70. We are taking the assumed mean as 70 because the lowest value is 50 and highest value is 90, where to be in safe side we are taking the mid value of the series. So after that we have to find out the deviations. It is nothing but x minus a. So this is the x. So first we are finding out the deviation for first value. It is 50 minus 70. 50 minus 70, it comes to minus 20. So next it is 60 minus 70. It comes to minus 10. So we have to deduct assumed mean from every x value. We have to deduct assumed mean from every x value. We shall not do in a reverse manner. So reverse manner means a minus x we shall not do. So arithmetic mean we shall not deduct x values from arithmetic mean. So for example this is 80. So we have to write 80 minus 70, but not 70 minus 80. So it will give some other result. So for we have to remember this specific issue while we are calculating this specific problem. So next assumed mean is here 70. So 70 minus 70 is 0. 80 minus 70 is 10. 60 minus 70 is minus 10. 70 minus 70 is again 0. 50 minus 70 is minus 20. 90 minus 70 is 20. So after that we have to sum up this deviations. To sum up these deviations, first we have to write the x value, write the positive values. Here the positive values are given. The positive values are, this is 20 and this is 10. So total positive values are 30. So negative values, next we have to write the negative values. This is 20, 10, 30, 40, 50, 60. So here the 60. So in this problem, positive values are 30, negative values are 60. So the sign of the negative values is more. So again in that answer we have to write the sign of the negative values. So from 60 to 30, if you deduct, it comes to the 30. So minus 30, we are getting minus 30 because the minus value is more than the plus values. After calculation of deviation and summing up the deviations, we have to find out, we have to substitute these values in the given formula. The formula is sigma arithmetic mean is equal to a plus sigma d by n. Sigma d by n. So here the assumed mean is 70 plus sigma d. Sigma d means minus 30. So n means the given values. So given number of values given. Here the number of values is 8. So 30 by 8 is equal to minus 30 by 8. So again, so minus 30 by 8. Minus 30 by 8. We have to find this by calculation. It comes to 3.75. Minus 3.75. It comes to minus 3.75. So here again, this plus into minus 3.75. So here also must observe, it is plus, it is minus. So plus into minus. If it is a plus, we have to add this. So 70 minus 3.758 comes to 66.25. it comes to 66.25. So in this way, in this manner, in this pattern, we have to do arithmetic mean, individual observations, indirect method. In this method there are two specific issues. First, taking of the assumed mean. You can take any value as assumed mean. It may be in the series, it may be out of the series, but it is better to take value that middle of the value, lower value to higher value. It is the lower value is 50 and higher value is 90. We are taking the middle value as a assumed mean. So after that we have to deduct assumed mean from every value. We have to deduct assumed mean from every. From that assumed mean is 70. We are deducting 70 from each value. We are deducting 70 from each value. In that way, we will get the deviations. We have to sum up the deviations. It comes to minus 30. After we are getting these values, we have to substitute these values in the given formula. It is arithmetic mean is equal to a plus sigma d by n. It is a is assumed mean. Sigma d means the sum up value of the deviations. N is the number of values given. It is the number of values given is 8. So in the entire calculation, at the end the value comes to 66.25. so this is the second problem in this value. So another problem I will give you right on the board. You try and you will get that answer. So this is the third problem, arithmetic mean, individual observations, indirect method. This is the third problem, arithmetic mean, individual observations, indirect method. I am reading this problem. Monthly savings data of 9 companies are given below. Compute arithmetic mean. Company 1, 2, 3, 4, 5. It is given up to 9. And the savings in lakhs, the value is given in lakhs. It's 10, 20, 40, 35, 65, 80, 90, 20, 45. So this is the data given. So I request you all to solve this problem on your own and find out whether it is correct or not. The answer to this problem comes to is 45. Answer to this problem comes to is 45. I further request you all to take 50 as the assumed mean. 50 as the assumed mean and solve this problem and check whether you got the same answer or not. Thank you.